Solving linear equations with graphing. The root or solution of an equation is any value that makes the equation set equal to 0 or where the line crosses the x-axis. So in the example below, if we solved here, if we started to solve this out and we have 0 equals 2x minus 8, then we would be able to solve and say that x equals 4. So we would be able to identify our root is 4, our solution is 4, the x-intercept is 4, and if this was in the form of a function, then our function of x would also be 4. So this particular number can be identified in a variety of different forms. So let's look at solving an equation with one root. So this equation, 0 equals 1/3 x minus 2. So you're beginning to solve and you're trying to solve for the x. So you start out by adding 2 to both sides. So we have 2 equals 1/3 x. To get the 1/3, you have to multiply both sides by 3 over 1. So those go away. We multiply this by 3 over 1. And we get 6 equals x. So the root is 6, or the solution is 6. It is just one root or one solution. You can also solve this example here by graphing. So we have 3x plus 1 equals negative 2. The first thing you want to do is you want to find the related function. So you want this to come out to be a function. So your step 1 is to set it equal to 0. So you have 3x plus 1 equals negative 2. We need to get this set to 0. So to do that, if we add 2 to this side, we add 2 to this side, we have 3x plus 3 equals 0. So we've set our equation to 0. So now we have the function f(x) equals 3x plus 3. And then we can begin to make a table for this to identify what our points are. So we first want to begin by making a table. The table has to include somewhere for our x values, our function, what we end up getting for our function, and our new coordinate points. So you always want to try to use a negative and a positive number so that you can try to get the graph to go across the coordinate plane. So we're going to use negative 2 and 1. So if I replace my x with negative 2, I have 3 times negative 2, which is negative 6, plus 3, which gives me negative 3. So my coordinate points would be negative 2, negative 3. My next value, if I plug in 1 for x, I get 3 plus 3, which is 6. So I have 1, 6. So now I would be able to graph this, and I would go over negative 2 and down a negative 3, and so I would have my point here. My next point would be over 1 and up 6. So I could put my point here, and then I could connect the 2 points to demonstrate the line as a graph. Now, when you have this graph, to find the solution of the equation, the solution is actually where it crosses the x-axis. And my graph was off just a little bit, but it should intercept at negative 1. And so you would be able to say that the solution for this equation is negative 1. Pause the video to try the example below. Solve the equation by graphing. So the first step is to find the related function. So you have to set the equation equal to 0, which it already is. So the function for this would be fx equals 2x plus 6. So we create our table. And 2x plus 6 goes in the middle. We're going to use -2 and 1. So if we put -2 in for x, we have -8 plus 6, which would be -2. So we have -2, -2. Then if we put 1 in for x, we have 2 plus 6, which is 8. And we have 1, 8. And I'll kind of sketch my graph up here in the corner. So if we have 2, -2, and then we have 1 and 8, and if we connect our line, we would be able to say that the solution for this expression would be -1, because that's where the line crosses the x-axis. Let's take a look at this example of an equation with no solution. So if you're trying to solve this equation and you wanted to get it set equal to 0, you would begin by subtracting 7 from both sides. So we have 3x equals 3x minus 6. But then if you subtract the 3x to get our 0, we have 0 is -6. So if we were to graph a number like this, where this is representing the graph, this is what our graph would look like, which would be no solution because it does not cross anywhere on the x-axis. Here's another example solving for no solution by graphing. So you first want to add 6 to both sides. So we have 2x minus 2 equals 2x. So as we simplify down, we would subtract 2x from both sides, which would give us -2 equals 0. So if we graphed the related function, which would be fx equals -2, then the graph of the line would not intersect I'm sorry, this is a positive up here, sorry. Then it would not intersect the y or the x-axis again. So if I had my graph, this is what my graph would look like, because my x would be 0 and my y would have been +2, so we would have gone up to +2 and would have graphed it, and because it does not intercept the y-axis, then it is a no solution. Pause the video to complete the lesson review. Solve each of these examples by graphing the function and graphing the equation and determining if it is a equation based on the graph, finding out if it intercepts the x-axis. Make sure you show me the graph and this lesson review for verification.